Good morning all students. Today we meet again in online learning SMPG Penabur. Today is our second meeting at grade 9. Today's topic is electron configuration of Bohr. Electron configuration. What is electron configuration? Electron configuration is set of electrons on atomic shell. At the first time, electron configuration is proposed by Niels Bohr. Do you still remember with periodic table of element? This periodic table of element is made by Russian scientist named Dmitry Mendeleev. Periodic table of elements. From the figure of periodic table of the elements, at the first period, from the left to the right, at the left side there is hydrogen atoms at the first period, and at the right side there is helium atoms. At the second period there is lithium atoms. Beside lithium atoms at the right there is beryllium atoms, boron atoms, carbon atoms, nitrogen atoms, oxygen atoms, fluorine atoms, and neon atoms. And at the third period there is sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. And at the first group, from above to downward, there is hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. And at the group 2A, there is beryllium, magnesium, calcium, strontium, barium, and radium. This set of atoms is related with electron configuration. Because at the first time electron configuration is proposed by Niels Bohr, electron configuration is usually called as Bohr's electron configuration. With electron configuration, we can know period and group an atom in periodic table of an element. An atom is depicted as the figure. From the figure, the atom, there is atomic nucleus and there is atomic shells where electron located. The first shell is shell K with number of shell n equals 1, maximum 2 electrons. The second shell is shell L with number of shell n equals 2 with maximum 8 electrons. The third shell is shell M with number of shell n equals 3, maximum 18 electrons. The fourth shell is shell N, number of shell n equals 4, maximum 32 electrons. Orbit that through by electron is called as atomic shell. Shell K, L, M, N, as we have learned from the figure. Second, number of electrons that fill each electron shell is stated by formula 2n square, with n is number of shell. Third, electron configuration on Bohr model, electron will fill the first shell, the rest will fill the second shell, third shell, fourth shell, and so on. Bohr's atomic model just can explain electron configuration for atoms that have atomic number smaller than 18 until 18. For atoms that have atomic number bigger than 18 can be explained using Aufbau principle. The first example of Bohr's electron configuration. From periodic table of element, for nuclide 7 and 14, nitrogen has atomic number 7. This is as like we learned at the previous meeting. So, number of proton of nitrogen equals 7. Because atom nitrogen is neutral, number of electron is equals with number of proton equals 7. And we should remember that number of electron that fill its electron shell is stated by formula 2n squared, with n is number of shell. And the electron will fill first shell and the rest will fill second shell and third shell. Because number electron of nitrogen is 7, so at the first time, electron will fill shell K with number of shell n equals 1. That at shell K, maximum electron fills 2 times 1 square equals 2. The rest 5 electrons will fill the second shell L, n equals 2. So electron configuration for nitrogen is 2, 5. The model for atom nitrogen can be seen at the right figure. As we can see, at the first shell, shell K, there are 2 electrons. And at the second shell, shell L, there are 5 electrons. The second example, Bohr electron configuration. From periodic table of element, for nucleate 12 Mg24 magnesium has atomic number 12. So number of proton of magnesium equals 12. Because atom magnesium is neutral, number of electron is equals with number of proton equals 12. Because number electron of magnesium is 12, so first electron will fill shell K, that n equals 1. That at shell K, maximum electron fills 2 times 1 square equals 2. The restant electrons will fill the second shell, L, n equals 2. That at shell L, maximum electron fills 2 times 2 square equals 8. So, at the atom, already fill 10 electrons. So, there are 2 electron rest. The rest 2 electron will fill the third shell, M, n equals 3. So, electron configuration for magnesium is 2, 8, 2. The model for atom magnesium can be seen at the right figure. In here we can see that at shell K there are 2 electrons. The second shell, shell L, there are 8 electrons, and at the third shell, shell M, there are 2 electrons. The other example Bohr electron configuration with its atomic model. First we see there is element and electron configuration. For element lithium with atomic number 3, electron configuration 2, 1. For element fluorine with atomic number 9, electron configuration 2, 7. For element magnesium with atomic number 12, electron configuration 2, 8, 2, as we learned. And the last, for element calcium with atomic number 20, electron configuration 2, 8, 8, 2. The third shell doesn't fill with 10 electrons. For stable condition, the third shell will fill 8 electrons and the rest 2 electrons at the fourth shell for atom calcium. And this is the atomic model, the figure for atomic model Li. At the first shell there are 2 electrons, and at the second shell there are 1 electron. And this is atomic model for fluoride. The first shell there are 2 electrons, and the second shell there are 7 electrons. And the last, for atomic model magnesium, at the first shell there are 2 electrons, the second shell there are 8 electrons, and the third shell there are 2 electrons. Stability of atoms. The stability of atoms depends on whether or not their outermost shell is fully filled with electrons. If the outer shell is fully filled with electrons, the electronic configuration of atom is stable. The atom that the outermost shell aren't fully filled with electrons, the electronic configuration of atom is unstable. Because of that, the atom will catch or release electron to make the electronic configuration of atom become stable. The first shell K stable if fills 2 electrons. This stability is called as duplet. The second shell L stable if fills 8 electrons. This stability is called as octet. Electron configuration on ions. Before we talk about electron configuration on ions, first we will learn about ion definition. Ion is atom that lost or gain of one or more electrons to make electron configuration of atom become stable. Positive ion, cation, is an atom that lost electron. Negative ion, anion, is an atom that gain electron. Sample: how many electrons on ion 11 Na positive make its electron configuration? As we know that atom Na, sodium, has proton number 11. It means atom Na have 11 electrons with electronic configuration 2, 8, 1. Positive ion is an atom that lost electron. So ion 11 Na positive means atom Na release 1 electron. That make in atom Na its number of proton still 11, but number of electron in atom Na equals 11 minus 1 equals 10. So electron configuration of 11 Na positive that has 10 electrons is 2, 8. This process can be seen on the right figure. Sodium atom Na with electronic configuration 2, 8, 1. To make the stability, the outermost electron at the outermost shell will be released. So the sodium atom becomes sodium ion with electronic configuration 2, 8. the second example. How many electrons on ion 3Li positive make its electronic configuration? As we know that atom Li has proton number 3, it means atom Li have 3 electrons with electronic configuration 2, 1. Positive ion is an atom that lost electron, so ion 3Li positive means atom Li release 1 electrons. That make in atom Li its number of protons still 3, but number of electrons in atom Li equals 3 minus 1 equals 2. So electronic configuration of 3Li positive that has 2 electrons is 2. The process can be seen on the figure below. The atom lithium or lithium atom that neutral configuration is 2, 1. That at the first shell there are 2 electrons and at the second shell there is 1 electron. To make the stability, the electron at the outermost shell will be released. Because of that, the atom lithium become lithium ion with electronic configuration 2. The third example, how many electrons on ion 8O negative 2 make its electron configuration? As we know that atom O has proton number 8. It means atom O have 8 electrons with electronic configuration 2, 6. Negative ion is an atom that gain electron. So ion 8O negative 2 means atom O gain 2 electrons. That make in atom O number of protons still 8, but number of electrons in atom O equals 8 plus 2 equals 10. So electronic configuration of 8O negative 2 that has 10 electrons is 2, 8. The process can be seen on the figure below. First, oxygen atom has electronic configuration 2, 6. To make the stability at the second shell, gain 2 electrons. So oxygen atom become oxygen ion and the electronic configuration become 2, 8. I think that's all our materials today. I hope all of you can understand these materials, and we will see at the next materials.